Good afternoon. In my current profile, I do address a large number of such meetings. Anywhere ranging from 5 to 5,000 people in one gathering. But I'm extremely honored and humbled to talk to this audience, primarily because, to repeat one of what one of the previous speakers told, I am what I am today thanks to my teachers. One who taught from my kindergarten to my engineering. Once again, I am an alumnus of PhD College of Technology, Coimbatore, like Chakravarti. And there's also a second reason for that, and I am extremely proud about it. Both my parents are teachers. My father retired as a zoology professor, and my mother retired as the principal of a school. And that makes me even more feeling very close to the teaching community. All right, I think I missed my clicker. Yeah, thank you. All right, so since morning, a lot of people talked about AI, artificial intelligence, machine learning, and things like that. There are multiple mentions. In fact, I'm not able to think of at least one speaker who didn't utter this word AI or machine learning. And NVIDIA is now doing a lot of great things in this particular space, and I'm really honored to head that business practice in NVIDIA. So, over the first 5 minutes or so, I'm going to introduce a very interesting technology, which is called as deep learning. Many of you might have heard about it. For some of you, it might be a bit new. And deep learning is actually a part of machine learning. So, a lot of amazing achievements have happened in the area of AI in the near past. It could be something as simple as creating your own machine learning algorithms to the epitome of machine learning that is called as autonomous vehicles, the self-driven cars and things like that. Music synthesizing, voice synthesizing, identifying objects of interest, and surveillance cameras and drones and whatnots. Everything is now driven by artificial intelligence. And deep learning is playing a very, very big role in this particular area. So what exactly is deep learning? AI has been there for long. In fact, you'll be surprised that AI has been there since the 1950s. And then came machine learning. I always explain the difference between machine learning and deep learning with the help of a simple example. So what exactly is deep learning? Let me explain that. How does a child know? Let's say take the case of an 8-month-old child. How does the child know that an apple is an apple? That's because the parent gave the apple to the child and attached a label to it. The parent said, hey, this object has a label attached to it, and the label is apple. And the human brain has been architected so well by God that you teach that a child maybe 2 or 3 times, the 8-month-old child will be able to learn from the object and the label attached to it and associate one to the other. And 5 days later, you give the child a different apple, which is maybe green in color. It is no longer red in color. It might be much smaller in size and maybe a slightly different shape with maybe a stalk and leaves attached to it at all. Even then, the human brain is able to identify that the new object is also an apple. Okay. So how does this learn? This is what the human brain does. When the first apple was given to the child and the parent associated label to it, the child sort of extracted features from that object. It understood how the geometry is made of, what are the nitty-gritties that go into defining that object, and learn from the data that is provided by the parent. And when a similar data is provided to the child 5 days later, it is able to correlate to the learning it had undergone. It is able to correlate to the training that it had undergone, and hence infer that the new object is also an apple. This precisely is the approach for deep learning. In deep learning, we actually try to mimic the human brain. I'm using the term mimic. We are not trying to replicate the human brain. Thank God. It has not happened, and I hope that it doesn't happen. I always want humans to be superior to machines. So, in deep learning, what we do is we write algorithms. And the algorithms enable the machine to learn from data. You provide large amounts of data, enormous amounts of data to the machine. And the algorithms enable the machine to extract features from the data and understand when a similar object or similar data is provided to the machine, it is able to pick out the commonalities and the patterns from the data and understand that the new object is also same as the old object that is given to us. This is the approach for deep learning. And how is it different from a traditional machine learning tool? In traditional machine learning, what we have been doing is we created mathematical models, handcrafted features that describe the object. It was not done through training through data. It was creating mathematical models that define or describe an object. I mean, this obviously has, there are human limitations to it, and that is where machine learning hit a plateau. It never went beyond a certain limit, and that is where deep learning, which actually had a revision very recently. The neural networks had a big revolution as recent as the late 2010s, the early 2010s, and that is where deep learning is taking, is getting a lot of interest and is getting employed in almost every vertical that we are talking about. So the next interesting question is, how come this particular terminology many of us have not even heard until about 4 or 5 years ago? Suddenly, this is a new technology that has come up, and everybody is talking about it, and every walk of life, from autonomous vehicles to drones to healthcare to industrial IoT, everybody is getting impacted by it. What led to this? What are the drivers for this? The first one is the sudden availability of big data. Now, let's look at the few examples here. If I take the third example, 300 hours of video get uploaded every minute. That translates to about 50 hours of video every second. 1 second and 50 hours of video has already gone into the internet. And 1 terabyte of sensor data is generated by a turbine by every flying aircraft. So, from these two different channels, which is social media and industrial IoT, enormous amounts of data suddenly got generated. The next question that comes into play is, if so much data suddenly becomes available, isn't it imperative for me to come out with new machine learning techniques that can make use of the data? Because the conventional machine learning cannot make use of the data. You need to handcraft features. Now, can I come out with a new machine learning methodology that can make use of the data, learn from the data, and predict outcomes? That is when the data scientists started developing more about this particular technology called as deep learning technology. And of course, this needs a lot of extremely large amount of computational power, and the computational power provided by the GPUs, certainly because of the parallel computing algorithms that they support, because of the parallel computing platform on which they work, that really helped in improving this science to what it is today. So we keep on hearing that deep learning is the next wave, and deep artificial intelligence, with particularly focus on deep learning, that is going to take it to the next level. A lot of jobs are going to be created, lots of jobs are going to be displaced. We keep hearing a lot of things about it. So how good is this? That's something which we need to answer. That's an important question to be answered. Look at the first box. So this is the levels of accuracy of prediction for one particular problem. I mean, it's a very golden benchmark which is called as ImageNet. I mean, many of you who might have worked in this area will know about this, ImageNet. I mean, later on you can go and look for it. That's a very commonly agreed golden benchmark used for machine learning and artificial intelligence studies. So, at the bottom of the graph, you see the accuracy levels that were hit by the conventional machine learning techniques. And as we described earlier, it sort of hit a bottleneck at around 75–76%. It never went beyond that. And deep learning, as you can see, it started like in 2012, it was like 80% accuracy, and today we are talking about 96+% of accuracy. That is the levels of accuracy that we are talking about when it comes to deep learning methodologies. Now, is 96.3 good or bad? Maybe 96.3 is not good. I mean, what is the gold benchmark for? Maybe 99 is good, or maybe 90 itself is good. I mean, why should I worry about 96.3? So, what should be the benchmark against which I should measure the efficiency of this number, golden number called 96.3? That is none other than the human levels of prediction for that same problem, isn't it? If my machine can give an accuracy which is equal to or even better than the human levels of prediction for that particular problem, then I am convinced that yes, this can be rolled out for actual production. And you can see that it has already crossed the human levels of prediction for this particular problem. Now, don't get me wrong. I am not claiming that for every deep learning problem, you will hit 96.3% accuracy. No, certainly not. But this is a golden benchmark which is very commonly used and accepted by the scientific community like you. And this is sort of an evidence, and it sort of gives us a comfort. Yes, we are marching in the right direction. Now, so where is deep learning used? Deep learning is used, the answer is everywhere. From internet and cloud to language translation, speech and natural language processing is a huge area of application so far as deep learning is concerned. When I am delivering this talk in English, if you want to hear it in Telugu or Tamil or Kannada or Spanish or Mandarin, it is possible almost near real time, and machines can translate my talk as I talk in the language that you want to hear, and you can wear your headsets and hear it in my language, in my voice. Okay? That is possible through deep learning. Medicine, biology, healthcare. A couple of speakers, in fact, mentioned about it. This is a huge area in which deep learning is making huge impacts. Things like digital radiology. See, today, how does a radiologist diagnose an X-ray? I mean, or an MRI image or a CT scan? By looking at images and identifying unwanted blemishes or lesions or aberrations in the image. This is fast getting replaced by machines. And the future radiologist is not going to diagnose images. The future radiologist is only going to approve the diagnosis that is made by the machine. That is where we are going towards. Media and entertainment, huge area in which, once again, deep learning is getting applied. Like machine, how does editing happen? How do people put statutory warnings on a movie, like cigarette smoking is injurious to health? Or how do people prune off content which is not good for kids? Violent scenes, etc. Some people sit and look at hours and hours of video, stop the video at the right point in time, and take the right action. Now, this is fast getting replaced by machines. Once again, all these things, if you look at it, it boils down to computer vision plus using machine intelligence to identify what is that the machine is looking at. Okay. Security and defense, huge area once again. All the smart city initiatives that we are talking about, and the smart cameras that we are talking about, in 2020 there are expected to be about 50 billion cameras worldwide. Everything is dependent on this particular technology. I'll give a simple example. PIDS, perimeter intrusion detection systems, which is basically, I mean, there's an airport and there's the parapet wall all around the airport, and there are cameras that are looking at it. There could be like 100 cameras in order to ensure that the entire periphery of the airport is monitored. Now, obviously, there is no human, a set of human beings cannot look at the feed from 100 cameras and keep diagnosing images. And this is what is getting replaced by machines today. Now, this is an interesting example. Like, let us say a monkey jumps over the wall. It's not a security threat. It will happen. Monkeys do jump over the compound wall of airports. But if a human being scales the wall, it is absolutely a security threat. A human being is not expected to scale the compound wall of an airport. Now, how does the machine identify a monkey from a human being? And when it is a human being, how does it raise a threat? Okay, somebody crossing the wall. Animals cross the border between our country and the neighboring country, no problem. But if a human being crosses, how does it raise an alarm? These are things where security and defense surveillance is leading a lot towards AI. Autonomous machines, I'm not going to talk much about it. The epitome of deep learning, the epitome of artificial intelligence, is self-driving cars. If I'm looking at, I mean, the car I'm driving is going to merge with the road, is going to merge with another road. What are all the precautions that I will take? I do inadvertently. I look at the periphery, I look at the front, I look at the signal, I slow down, I ensure I have peripheral vision, I have front, I do everything. And the same thing has to be done by the machine, if not in a better way, at least as good as me driving the car. That is when autonomous vehicles will become truth. And today we are very, very fast marching towards the reality of getting fully autonomous vehicle rolled out in production. Research, testing, it is already done. See, I'm talking about the globe, I'm not talking about Bangalore or India. Yeah, I'm talking about the global. It's already done, but actual production will happen very soon. Now, I think we talked about this. Is it only for technology? Not really. It also has a huge, huge impact on the socio-economic aspects of human life as well. Mapping an end to poverty, poverty prediction, geological disaster recognition. How do you recognize the problems? Like there is a vast expanse of forest, and smoke comes out of one particular patch. Satellite images keep on capturing that. But how do you identify that smoke is coming out of that? How do you take corrective action? That is done through computer vision and deep learning, and monitoring global deforestation and things like that. So, we have discussed a lot about the technology, and the technology is extremely, extremely complex and advanced. But that the complexity that goes into describing the technology, creating the technology is also growing exponentially. This is sort of an example. Like if in 2015, which was just 2 years ago, what could have been achieved using 7 exaflops, which the problem was described using 60 million parameters, is now we are talking about in 2017, just 2 years later, 100 exaflops was needed to solve a similar problem. It's not the same problem, it's a similar problem, and 8,000 million parameters are getting into defining that. So basically the idea is that the technology is growing at breakneck speed. And how do you keep in pace with this technology, and how do you supply the brutal machine power, the brutal computational power that is needed to solve the problems? That is where NVIDIA plays a really big role. And there are multiple, it's a very advanced science, I would say, both in terms of the hardware that is involved in it and the software that wraps around it. There are multiple, at the bottom level, base level, there are multiple SDKs and libraries that are needed to build these models. And there is something called as a frameworks, which are basically templates into which you can fit your models and your data and do the training and look for the results. And on top of everything lies the applications, which can basically be compartmentalized into 3 major buckets, which is computer vision, speech and audio, and natural language processing. These are the 3 major buckets into which these problems can be compartmentalized. Now, how do you manage this complexity? If this is the software that we are talking about, in terms of the hardware also, there are lots of huge developments that are happening, and extremely big technological advancements are happening. This is one example of what this is our own offering. I mean, there's an AI supercomputing machine today. I mean, there is a machine called DGX1, which is a AI supercomputing machine. It is specifically architected supercomputing machine for running AI problems, for running deep learning problems. I mean, and it's an extremely, don't have to mention that it's an extremely complex, advanced machine. Look at the numbers. I mean, people who are involved in the high performance computing and computer science area will understand this. It can deliver 960 teraflops. That is about 40 teraflops, just short of 1 petaflop. And that comes out of one machine. Okay. So this is the way technology is growing, both from the software and hardware point of view, in order to keep in pace with the breakneck speed at which the base technology, which is AI, is growing. Now, how do colleges keep in pace with this? I mean, isn't it? I mean, I'm not going to tell that it's important that we reskill. I mean, those things have been talked a lot. I'm not going to repeat that. How do we keep in pace with technology so far as academia is concerned? And NVIDIA has a lot of tools which are specifically meant for academicians. The topmost amongst them is what we call as a Deep Learning Institute. And this is a training program run by NVIDIA to skill people on basic programming techniques that are needed to create algorithms in deep learning. Okay. I mean, the person who needs to undergo it need not be a machine learning scientist, need not be a computer science. I mean, obviously, it's good to have a computer science background, computer science or an easy background. So long as the person has a programming approach, so long as he or she knows how to write a program, what is the programmatic approach that is needed, and certainly analytical and mathematical thinking and skills, that person can certainly undertake this particular program, which is called as Deep Learning Institute. And from NVIDIA, we have lots and lots of ways in which we collaborate with academia in order to ensure the skill set needed in this particular AI program. Even before I go through the list, let me answer one question. Why do we do this? Why does NVIDIA get into this? The answer is simple. We strongly believe that unless the ecosystem gets skilled in this area, the science is not going to grow. Unless the academia, maybe the professors who offer who have been offering conventional machine learning program, they get into the new way of teaching and learn the new skill set, and the graduates and come out and in fact the postgraduates and the research that happens in the area turns over to this new particular way of computation, the science is not going to grow. And as a pioneer in this particular science, we do all efforts to ensure that we help academia to come out with the right skill set, first starting with the teachers and then which percolates down to research and the students. We do provide a lot of technology setup for universities that have plans to set up centers of excellence. We have worked with a lot of colleges. In fact, I can see a lot of I mean, at least a few of the colleges with whom we already have worked in this audience. And for those who want to set up a center of excellence and who are interested in buying the AI supercomputing machine that I mentioned about, we provide grants in order to make it easier for them to buy. And of course, I mentioned about the Deep Learning Institute, and there is a Deep Learning DLI ambassador program also available, which helps teachers to become ambassadors of this DLI. Basically, they are empowered, they are trained to offer training in deep learning. That is what the Deep Learning Ambassador program does. And of course, we have a developmental workforce of, I think, about 4,000 plus who are based out of India, spread over 3 cities, Bangalore, Pune, and Hyderabad. And there's a lot of expertise hidden inside the Indian workforce of NVIDIA, who are like core developers of these technologies. And we will be very happy to share that expertise and mentorship for research and teaching when it comes to AI. And of course, any technical support that is needed by the university, we very happily provide. And this is all towards, once again, I want to repeat that, this is all aimed at ensuring that the community, the teaching community, the academia, which comprises of the teachers and the students, they get empowered with this technology, and a lot of teaching and research happens in this technology. That is the sole aim of doing all these things. So to conclude, what could be your next steps? So if you are new to AI, I would really urge you to go to this DLI, go through it. This is all, there is online programs available, there is an instructor-led program available. We'll be very happy to share those details with you. There's a developer sign up. Please, encourage your students to sign up for this developer community. They will get a lot of nice tools in the form of trainings, early access to software, etc., that are available. And if you are in academia, please do go ahead and utilize the NVIDIA Educators program that I mentioned about. And in fact, something which is not mentioned in the slide is that there also is something called as a Educators Kit from NVIDIA, which basically is a full curriculum. Let's say, for example, you are planning to offer deep learning as an elective it could be for BTech or MTech. How do you start designing the course? What are the contents of the syllabus for one particular semester? And how do you create lab workshops? How do you create quizzes, answers to the quizzes, etc., etc.? The entire thing has been packaged into one particular kit, which is called as the Educators Kit, which is provided by NVIDIA. And it is strictly, you'll be interested to know that it is strictly given only to research and academia. It is not open for commercial use, and we'll be very happy to provide that to you. Okay. So that sort of concludes my presentation. I'll be here throughout the day, and I have my colleague Unni also, Unni Kishan, and he in fact leads the education initiatives for NVIDIA in India. Please reach out to either one of us if you want more information, and we'll be very happy to provide all the details. Thank you.